So the sum and difference formulas. Why are we going to use the sum and difference formula? I was thinking about doing a proof, and then I was like, why nobody really cares mostly about proofs unless you're mathematically astute and you're like, oh, I kind of enjoy and interested about this. But I think I'll make one a little bit later. But I just want to kind of give you guys a quick little rundown of why we're using the sum and difference formulas. If I said evaluate for one of my trigonometric functions for 75 degrees or 13 pi over 12, we would have a problem. And that's mostly because so far what we looked at as far as evaluating is we've looked at using the unit circle and finding an exact answer. You could plug this in your calculator and say the tangent of 75 degrees or the cosine of 13 pi over 12. But what's going to happen is you're going to get an approximation. And I want to show you a way that we can get an exact answer. And to do that, we're going to use the sum and difference formula. Now, before we get a little bit farther, I want you to understand that we're going to use this. We're going to say, like, what's the cosine of 75 degrees? And the sum and difference formula is pretty much just telling us that when doing the cosine of 75 degrees, we can't evaluate that. We can't go up to 75 degrees on the unit circle and say, oh, there's my x-coordinate, right? Because the unit circle we only work with, we only have the values for so many of our angles up on there. So if cosine 75 degrees, what we're going to do is we're going to break it down into two angles that we do know what the values are on the unit circle and the exact value for, like the cosine of 30 degrees plus 45 degrees. Now, the one big mistake I want you guys to understand is that does not equal the cosine of 30 degrees plus the cosine of 45 degrees. It's the same thing if I said the square root of 9 plus 4. That does not equal the square root of 9 plus the square root of 4. So the square root function, just like the cosine function, we can't distribute that under addition and subtraction. So we're going to learn how we can work upon this, but you need to understand that you can't just when I rewrite this cosine 30 degrees 45 degrees, that does not mean this. What I'm going to do is I'm going to introduce two new formulas for you. Well, actually, I'm going to introduce formulas for all of my angles. So we do that with sum, where we can write this as 30 degrees plus 45 degrees. And we also do this with radians. When I want to look at this one, if I say 13 pi over 12, I could say that's the same thing as 4 pi over 3 minus pi over 4. And you might say, well, how is 13 pi over 12 4 pi divided by 3 minus pi over 4? Now, one thing to notice is since my denominators are in thirds and in fourths, we know that they're on the unit circle because that's how we started creating the unit circle. So if I needed to subtract these, I would have to get common denominators, right? And I multiply by 3 over 3, 3 over 3 here. And therefore, I'd have 16 pi over 12 minus 3 pi over 12, which ends up equaling 13 pi over 12. But 13 pi over 12 is not an angle that we have on the unit circle that we can easily evaluate for. So therefore, we're going to use our angles 4 pi over 3 and pi over 4 to help us evaluate for them. So I'm going to go and show you some videos on how to find the sum and difference formulas, and then we're going to work into how to evaluate them. But I just want to kind of give a quick little overview of why we're going to use them. Because for angles that we can't evaluate for, get the exact value, we need to separate them in either to an addition or a subtraction, and then we can use our formulas to help evaluate. There you go.